Hello, everybody. So yeah, the problem we are going to tell you a little bit about is how to detect catchy phrases in Polish internet and catchy topics, potentially also in Polish internet. And we'll also talk a little bit about how to solve this problem that data is really not there, how to get it. And at the end, if you have some questions, we're happy to talk a little bit about it. Okay, cool. So why even bother? So FinAI is a startup, so we're like 9 months old, 10 months old, and we have a marketing department. And the marketing department has to do a lot of stuff, but one of it is actually write content for our website so that people come in and read and get traffic. So they wanted to know what they can write about. If they're marketing, you should know, right? And what makes people click, if anything. So they came to me and said, "Hey, dude, can you help? You're supposed to be like data shit stuff, you know, wizards, you know, spells." And we said, "Okay, we can try." And actually, we did it. It's not complete success, but it actually helps them with work. The problem we needed to solve is that we don't really know what makes people click because we didn't hack yet Gazeta.pl, Super Express.pl, and other things. But we do have social networks, and people are super, you know, extrovert there, and they click like, love, and stuff. So we can use this as a surrogate for some reaction time. So this is a story about how we made our marketing guys' life a little bit better. So as with anything in data science, we try to follow a process. Having worked in consulting for like over 10 years, I know, and starting some data science projects for financial services, I know that this is actually not very obvious for most of the business guys, because usually they, hey, here's some data, figure out shit, right? Data is new, so solve me problems. So we actually first defined a problem statement, improve life of our marketing guys so they have inspirations to write topics and texts, and how to improve existing texts, their headlines, if possible, in a measurable way so that people click more. That was the problem statement. It is actually done in a measurable way. Then we said, okay, we never done that before, so maybe we'll select some tools. Turns out my team knows some Python, so we figured out that we might use some Python. We didn't want to write scrapers for all the internet because that's fucking boring. So we decided we use something called Senti1 because marketing checks whether someone writes about FinAI. Maybe it's good, maybe it's bad, but it's good to know. So it takes some work out of us. Then we did some research. Michał will tell about some packages we used. So which packages we used. Then we needed to get some data. So we used Senti1 API. Turns out they have API, so we used it. We got a data set that makes modeling a little bit easier. And then obviously the cool shit, data engineering, feature engineering, modeling, hyperparameters tuning. So we talk a little bit about that. Turns out it's not very obvious in the text space. And actually something that no data scientist wants, as they say, every model is great until it's actually applicated. So we actually made application of the model and deployed it to production. So this broke some things, but now it works. All right, Michał.
So Łukasz told us what was our problem. And so for that we need to gather some data to solve that problem. One of the sources of our data was Facebook Graph API. Oh, sorry. Now you can hear me? Okay, so one source of data was Facebook Graph API. It allows to download posts from selected fan page and a lot of data about this post, like number of shares, number of likes. Okay, number of likes and URL to shared content. And our marketing team gave us a list of these hosts, which we used to. Oh, maybe yes. Maybe it will be easier.
It's hard. Have you been here?
Can you hear me? I just use this.
This one is turned on.
Okay. So our marketing team gave us a list of most important Polish financial portals, and we are gathering data from this Facebook Graph API, which is hosted on Azure. There is daily scheduled web job, and another data source was Sentinel-1 API. It allows to download articles from selected list of hosts and a lot of other stuff like author of that article or URL to that article. And we use the data to find out what are the characteristics of the most popular articles shared on the Facebook. So in the previous year, we gathered 300,000 article text from Sentinel-1 API.
Can't believe how many stuff people write. Nobody reads it.
Yes, from this only from this list of hosts defined by our marketing team. We also downloaded 60,000 Facebook posts from Facebook Graph API, and we were able to join these two data sets by URL to this article, which we use to compute various statistics to train topic model and to describe these topics. Okay.
So we had the data sets, 30,000 articles. So first problem is, does headline matter? So does headline make anything? So first we needed to create like a measure of what is virality. What we named it virality in a way. Obviously, there is no agreed way, but we talked with our marketing guys and decided that there is a experts weighted combination of likes, shares, comments that we will use as a score of how attractive this text was. And we tagged and labeled every article in our database that Michał described in the previous step. Obviously, this is expert-based. However, clearly, we took into consideration the effort it is to make a like, to make a comment, and to make a share, and how much it is worth within marketing teams. After we had that, we were able to do some actual modeling, and now. Why did we? So there's like things like Saryusz Wolski considering the big candidate for election in European Union, but you can't really predict it, and it doesn't make sense to write it after it's written. So we needed to make some measures, invent some measures that will allow us to determine for something that's constant. I mean, it's not a one-time thing, and something that's coming up in a while, or is a one-time event. And for that, we use entropy. Michał will explain after on the next slide. So it turns out something is in the headline. The headline is actual predictor. So check that out, right? Ciężarówka wjechała. So terrorist attacks are cool. People like to read about it. People react about it. And that's actually sad. However, when we talk about social issues like kwota wolna, right, tax-free money, it actually generates a lot of buzz. In general, all the legislation effort in the current government generate quite a lot of buzz, unless they're super quiet, like this legislation that nobody knows about it. Saryusz-Wolski, right, one-hit wonder. You can't really predict that. Terrorist attacks, you can't really predict that, and it's hard to react, and especially doesn't make much sense in a financial services context, right? So what about something that works more constantly?
Okay, more constantly works phrases like "look out for." So
Yeah,
these are some
like twice the effect.
some tips about security, maybe, or something. And also, money is quite viral topic and constant over time. And also, things which are happening on Facebook are quite viral. Okay. We also checked what are good opening phrases for headlines of articles. And it turns out that good opening phrase is that someone is dead. And it's good opening phrases are about Polish companies and about yes, and about arguments, for example, or about our president.
Not our prime minister, not our chief.
Yes, he's our
the president.
He's our favorite.
And don't tell them that size doesn't matter. Size actually matters in terms of headlines. Actually, no. Actually, size matters. It turns out you can't be too long this time. You have to be rather on the short side. Turns out it's around 25, 30 letters in total is the best clickable things. And also don't make it too complicated. People don't like long headlines. They're boring. Like it means it's probably boring and it's hard and stuff. So clearly when we presented that to our marketing, it's like, oh shit. Okay, so now they write shorter topics, way shorter, and actually helped. Where's the thingy? Right, but we also did some analysis about the sequences, right?
Yes, we check what influence of how type of sentence influences virality. So the best phrases are exclamations, and the least favorite ones are questions. And the
Don't like to think. It's like,
yes, and the difference between these two is exclamations are 2 times better than questions. So it's quite big difference.
Yeah.
Okay, so all the analysis we did to this point only takes into account headlines of articles. If we want to get deeper, get better insights, we have to analyze content of the article, main text. But for that, we need a tool which allows us to get from any page we want an article we want. So we talk about that.
So because we had Senti1, you ask why would we do that? Somebody already extracted the text for us. But when you remember that we had 60,000 articles on Facebook and only 30,000 matches, so there's like another set the same size that we could extract if we had an automated way to extract text from a website. And clearly writing the bots to extract text isn't the case because it will take like hundreds and thousands of hours. So that's not cool enough. Clearly the problem is very easy visually, right? When you see humans are designed to read the text, and if the text is unreadable, the site will die because it will have no viewers. So for humans it's super easy. But for the computer, it's not that easy. Making an automated text extractor is actually a hot topic because you essentially need to build a Google bot. There are a lot of papers that solve this, offer hints to solve it visually. So render a page, measure the dimensions of the text fields, then create some extractor and extract the text using something like Selenium bot or other similar techniques. But this is super expensive. If you have 30,000 articles, you would have to build an engine that renders them, extracts it visually, train a neural network. This takes a lot of computational effort and a lot of money, actually. So for this small task, this is not a viable way. So we decided to use maybe a little less accurate way, but actually parse the text and see whether or not we can build a general machine that can extract article out of raw HTML, right? HTML is good enough. It is an instruction to our browser to render it. So maybe there is a model that can actually read it and extract the text out of it. So yeah, Michał, did we do something?
Yes. So I'll describe our approach for that problem. So first we extract all the text from a web page, any web page we want. And then we have to decide for each text whether it is article or not. And for that we need a classifier. But to train a classifier we need a dataset. So we have this dataset from Senti1 where we have a pair of each HTML code and text from that web page. So we've made a simple algorithm which labels text in any web page, whether it belongs to the article or not. And from that we have a data set which with auto labels. Sorry, I skipped a slide. First, about some feature engineering. So we've got a lot of this text, and for each text we have to describe in some numeric way. So so we can then train on classifier on it. So we computed for each text a lot of features like depth of the text in HTML3, number of words of the text, the text density, so the ratio of the number of characters to all the characters in that element. And we repeated the computations of these features for parents, grandparents, and we concatenated all these features into one long vector for one text. Okay. So we trained a classifier on this data set. We trained random forest and XGBoost. And we use hyperparameter tuning using group cross-validation, where group was defined by host. So group cross-validation is basically cross-validation where your faults are defined by values of some grouping variable. In our case, it was host because we didn't want to overfit too much to layouts of specific web portals, which were in our data set.
So essentially, we were training the classifier on certain hosts and then evaluating them on hosts they've never seen before.
And we trained two classifiers. We made an ensemble of them by simply averaging their predictions. Okay. So if we want to use our algorithm on new web page, we have to first extract all the text from that HTML code. Then for each text we compute features. Then for each text we classify whether it belongs to the article content or not. And text labeled as by our classifier as article are merged to one text, which we return as an article text. Okay, so we trained some classifiers, so we can tell what are the important features in our data set to decide whether it is article or not. Some of them were depth in HTML3, length of parent, number of symbols or number of characters in that tag.
say a little bit about the results. How to measure that, actually. It's a classifiers, but the accuracy or AUC is actually useless because I don't care about one line or one tag classification. There are other, right, precision recall, and we found one more, Jacquard index, and that's the actual results. Precision and recall has actually pretty good interpretation. So we extract 90% of the text that actually is there in total. So 90% of the articles is classified correctly. And the other thing is that of all things we extract, 90% is something that it's worth something, right? It's correct. So, and this is, how much did we spend it for? Like a week maybe, building this model, even less. And we see potential to maybe getting this thing to 95. And with 95% is actually pretty good because 95% in an automated way. And this is taking consideration its trained results on the hosts that the algorithm never sent before. Considering it's obviously Polish internet, but we can usually, I think, extrapolated that because people write content in a similar way, all languages using Latin alphabet should be similar. Obviously, Muslim, when it's written left to right, might be different. Probably Chinese would be a little bit different, but this should work. So we were pretty happy with that because 90% of the extraction should be there, and because the approach we used in the topic distinction, 90% was considered for us good enough. And usually because we want to predict topic of an article, topic doesn't usually care about 10% of article content. The topic is something that's general about the article, so 90% of correctness should be enough. All right, so about the topic. We wanted to know what topics are hot, because then I go to marketing, or actually they go to our dashboard and say, they know what they write about. They don't, fantasize too much, or they don't actually come to us and tell us for inspiration. So we needed some approach to topic modeling because having 60,000 articles is quite a lot to label. So we decided to automate that stuff.
Okay. Okay. But first we had to do some text pre-processing. So first we done some standard stuff like lemmatization, tokenization, stop words removal, interpunction removal, and lower casing. And then we done lemmatization. So basically we took each word and based on some dictionary of all the forms of all the words in Polish language, we transformed them to their base forms. And that was input to latent Dirichlet allocation. So it is a probabilistic graphical model which uses a lot of latent variables. It uses bag of words text representation, so it discards order of words in our data set. It extracts given number of topics characteristic for that set of texts. And each topic is a probabilistic distribution over words, so we can tell how likely each word is to occur in that topic. It also assigns topic probabilities for each text, so we can decide whether the text has a specific topic. And we used a GenSim package for that model. It allows to spread computations for multiple cores, and it's very fast.
Because I get really angry if we have an 8-core machine.
Yeah.
That's only 1 core is burning. It's wasting my money.
Okay, so the outputs of LDA is our topics and topic distributions for each document. So topics are probability distributions over words. So we can describe topics using the most probable words in that topic. So, for example, if we had these words like here, we can tell that first topic is about French presidential elections, and the second one is about pensions and retirement or something.
It's enough for our marketing team because they can see those 10, 15 words and then actually can make a mind map what this text is about and what topic is hot or not.
Okay, so we've got also these topic distributions for each article. So these are telling us how much of that topic is in the article. So these give us weights by which we can yes, or we can compute some exploratory statistics about which we tell Łukasz.
Yeah, cool. So, we like Macron. We're politics guys. So we did some reactions, what people are doing. Turns out that actually reactions are the ones we expect. Likes dominate. Likes are like 80% of all reactions in Facebook, because like is the default action. The second action is the love action, and the third one is the haha action. Check out. You see? So the more effort it makes to move it with a mouse, the harder it is to click it. If they moved this sad face to the first one, I guarantee you it would be the second best. So this is actually worthless information. But we did some analysis of what this LDA found on over the 60,000 articles. And turns out we had Shishkolo, a lot of coverage, guys. We had obviously a lot of political context, like, that legislation topics are super hot. So this abortion law, super hot. But we also found like financial results, like a lot of articles, Bankier PL or TVN or Money PL publishes results, and we classified those. Some random bullshit like he changed name to iPhone 7 and got like there's like a classification we had random shit, and this is one of random shit. Like PR texts, we have a lot of PR texts where the brand name occurs, because when you think about it, the brand name occurs in PR text because PR writes it, and every text has a lot of it, so it's quite easy to find. So what is viral? PR shit is not viral at all. Like financial results, not viral. Like generally things about like politics, non-Polish politics, not viral. But Lex Shishko, damn man. Everything about politics right now polarizes people, and there's like a statistical example that it actually makes sense to write about banking legislation and how it will affect you, like a regular dude, regular Joe, regular N. And that's a great insight we passed to the marketing team. Yeah. So how the topic over time looks. This is the presidential election, French presidential election. We can see that we can almost assume presidential election has a date, right? And based on the March and February like local maximum, you can almost make a model to predict that the date will get a lot of coverage, because the closer we get, the more clicking is there. So it turns out that there is a guesstimation that we can actually make about it. Yeah, Michał. So wrapping it up.
Okay, so now we are creating a pipeline hosted on Microsoft Azure, which allows to do all these analysis in real time, and as an output, it will present some report in Power BI. So we have a daily scheduled web job which downloads data from Facebook and Sentiwan, and also downloads articles and from web, and uses our algorithm for content extraction to. Yes, it's all in Python. Web job is just as Python script run every day on Azure. Outputs of this step are stored in Data Lake Store, which is something like HDFS, but on Azure. And then each week we have another web job, which is another Python script run every week, which takes data from this Data Lake Store, takes saved model from blob storage, updates the model, makes new predictions using that model on the data from Data Lake Store, saves this to SQL Server database, and to that database is the database is connected to Power BI, which generates reports for our marketing team.
So yeah, it looks all super easy, but how much curse words went through to make it actually? Yeah, so it's actually done, but if you're doing it for the first time on Azure, it's a lot of pain, mostly about connecting things. But then it is very stable. It works like without any issues for like now a few months, and so yeah, and it's super cheap. Like one run costs like less than $1, so it's super cheap. Doesn't really matter. So yeah, after we deploy the Power BI, it's actually operational. Like guys log in every week on their content planning session and see what phrases are hot, what phrases should we begin our headlines with, or what topics we should write maybe within a week, month, or something like that. And their content plan is actually affected by what we did. And yeah, we also had a choice, a chance to make a presentation for you. I hope it wasn't too boring. So any questions, guys? Yes. Yeah, we measured the improvement on the headlines, if they change it, and it's statistically over 30 to 40% increase on an average basis to the reference, not including our regular user growth. Sorry? The clicks based on the whenever the article was shown. Yes, we have implemented A/B testing in all our article titles, and that's how we can measure the effect. Yeah, because LDA output is a vector of whatever amount, length you want. But we tested with marketing people how many words do they need in order to actually describe, understand what the topic is about. And it turns out it's between 10 to 15. Depends on how, because on, so yeah, but this is the hyperparameters of LDA. So you can tell them to find how many topics you want and how general or how deep should they be. And we wanted pretty specific topics in this case. So therefore, you don't need a lot of words to describe a topic about it, actually. And because it's no stop words, usually the word make a meaning to you instantly from reading. But the other question I think you want to ask is like, what's the cutoff point for an article to know what the article is about? And we decided that we use 20%, but this is pure expert judgment, and we wanted no more than 3 topics for article. But this is something that you can tune. Maybe you want 5 tags, maybe you want just the dominant article with at least 40% chance that this article is about. This is purely based on your use case. You can tune it. 100. But we will tune it along the way, I think. We think, because we observe how often the topics come up and disappear. So based on the number of articles we intake, in this case it's 60,000, it's for 1 year, and with our current host base. So you want to know how much of topics you cover, and you can optimize that based on what's the minimal virality you actually care about. And because we don't care about boring shit, we can limit ourselves to the number of topics. Turns out 100 topics is the amount you actually right now want to read about finance and social issues, because people don't need more right now. It's good enough.
Late and thank you very much.